do really like having the mat because it just shows me like where.
No, exactly. It's a good
where
virtual.
it is. Okay. Okay, welcome to Mathursday. Mathursday. If you guys have any math questions, concepts, concerns, regrets, stick them in the chat. We'll work through them. Oh yeah, I wasn't live last Thursday, huh? Because I was at my conference. I missed last week. I was sad.
Hashtag humble brag.
Hashtag humble brag. I'll miss it in February too when I go to back to Missouri.
You're going to miss it in 2 weeks.
Well, of course I'm going to miss it in 2 weeks, but you know. Oh no, reconnecting again.
Oh, that always gets in your head. So just favor YouTube once we get it going.
Lucas's secret account. Happy Mathursday. Oh, I'm going to do that right now while I'm thinking of it. Let's see if I can send this.
Oh, great. Okay, you're live on YouTube.
Live on YouTube. So if you are joining me on TikTok live and it keeps cutting out or anything, just, go over to the other place. Let me see. Yeah, let's see that one there. Okay. I just sent you that file. My love.
For the record, Lucas, I've been asking for it for days.
Sorry. I'm sorry. Okay. What is this that I'm seeing?
That's YouTube, dear.
Oh, YouTube can see all of this?
Yeah.
Oh, heavens. Let me put my phone away.
What's going on over here? What am I looking
Well,
at?
because... Oh. All right. Okay, so let's see. What are we going to do?
So there's chat over here as well.
Okay. You go over perpendicular bisectors. I have a math test tomorrow on it. Interesting. My students have a test over it on Monday. Yeah, perpendicular bisectors. So perpendicular means that it intersects at a 90-degree angle. And bisector means that it cuts it in half. So bisector, regardless of whether it's an angle bisector or a perpendicular bisector, like a line segment bisector or anything like that, bisector means that it cuts it in half. So a perpendicular bisector, what you would have, that's a terrible marker. Okay, so a perpendicular bisector, okay, if we have a line segment like this, okay, and then we've got this, and we say, okay, this is a perpendicular bisector. So perpendicular means that it's at a 90-degree angle, right? So we put that square that means it's 90 degrees, okay? And then what that would also mean is that this distance here is the same as this distance here, right? So those are two congruent distances. So we've got this here and this here are both congruent. So, so we've got, I mean, to be fair, even if you were my student, I'd still help you out. They join in a lot of times on Mathursdays. Okay, so if these two are congruent, okay, then whatever I know about them is actually like the same information, right? So I could say that this segment is 3x plus 2, okay? And I could say that this segment is, you okay, buddy? Is, let's see, 5x minus 4, okay? So what this is saying, actually, I meant to do this in the blue marker. Let's say this one is 5x minus 4. Okay, so we've got these two segments that they've got these two different expressions that are relating each other, but we've got, it's kind of like two bits of the two different ways of saying the same thing. So what we know is since this is a perpendicular bisector, so those are going to be congruent, right? So we mark congruency with those little hash marks like that. So then you've got 3x plus 2 equals 5x minus 4. Okay, again, because these two segments are congruent, that means that 3x plus 2, this measurement, is the same as this measurement. No matter what it is, they're the same because it's perpendicular bisector. So now I'm going to go ahead and I'm going to solve this just like I would. Once I have my equation set up, I'm just going to solve this like I would anything, right? So I've got 3x plus 6 equals 5x. And then I'm going to subtract 3x from both sides. And I have 6 equals 2x. So then divide by 2, divide by 2. So x equals 3. Okay. Now, a lot of times, sort of the follow-up, like the next question, would be something along the lines of like, what's the measurement of the whole distance, right? So then once you figure out your x value, sometimes they'll just ask you like, solve for x. But sometimes they'll ask like for the length of, you know, of segment AB, right? So they'll ask for the length of segment AB. So then you would take this x equals 3 and you would plug it in here. So 3 times 3 is 9. So 3 times 3 plus 2 equals 11. And then let's just double check. You know, things could have gone sideways, but we're just going to double check that it's also the same over here. So 5 times 3 minus 4. So that's 15 minus 4, which also equals 11. Phew. So segment AB, or the distance between A and B, is 22, right? Because this is 11 and this is 11. Okay. Okay. So another situation that this might show up with is, now let me know in the chat, are you needing to construct perpendicular bisectors, or is it just kind of questions along this line, right? Along these lines. So another situation that you might have, something like this, is, let's see. So if we have this, right, and this is perpendicular, ooh, oh, okay, you've got to construct them. Dang it. Dot. Hold on just a minute. I'm going to grab my coordinate plane. Dot. Okay. I left my coordinate plane dry erase boards out in the car. Okay. So we'll get to that in just a minute. Let me get my coordinate planes in just a minute. Can you run out to... Oh, Daddy's doing it. Never mind. Love you. Yeah, never mind. Sorry. Okay. So if we have this, right? So we have this coordinate plane, or sorry, we have this perpendicular bisector, right? So you might get something along the lines of Nemo. My goodness. Sorry, the dog's going nuts. Okay. So again, if you're told something like this is 26, this is 4x plus 1, right? And if you need to figure out what x is, right? So if you know that these are congruent because it says perpendicular bisector, right? So then half of this, so there's two ways of going about this. So either you know that half of this is 13, right? But let's say, let's kick it up a notch a little bit. Let's say that we've got, I don't know, this one is 15x minus 4. I have no idea what this is going to look like. This may be a disaster, but we'll see. It's probably going to be a fraction, but that's okay. All right, so if I'm having to solve for x, now, I know that I've got 4x plus 1 and 15x minus 4. So what I can do is I can say, well, if this is 4x plus 1, I know that this is also 4x plus 1, right? So what I'm actually looking at is if I add these together and I have 8x plus 2, that's the same thing as 15x minus 4, right? So I can add these together. So I could also do this like 2 times 4x plus 1, right? Thank you so much. Okay. So I could do this as 2 times 4x plus 1. So then I could solve for x. So I do plus 4, I do minus 8x, and I can do this all in one step. So I get 6 equals 7x. So yeah, it's going to be kind of an ugly fraction, but then you get x equals 6 over 7. So even though it's a fraction, like, that's still what it is, right? Doesn't mean it's wrong. Fractions don't mean that it's wrong. It's just a fraction. Okay, so now I've got my dry erase coordinate plane. So let's talk perpendicular on the coordinate plane. Okay. Okay. Got my times tables. This is my tutoring bag. So let's go. You know what? Let's do the big coordinate plane. Okay. So when you have a line, so perpendicular slope means that it's 90 degrees, right? Two perpendicular lines have the opposite reciprocal slope. So meaning, if the slope of my line is let's say it's 2/3. Okay. My perpendicular slope is -3/2. So I change the sign and I flip it. Okay. So if I have 2 points, right, on a line, okay, I go here to here. Okay. I'll use my straight edge because why not? Okay, we got that. Okay. All right, so there we go. So we've got this line constructed, right? So these points are, let's see, it's -1, -2. This one is -1, -2. This one is +3, +4. Okay. So the first part to construct a perpendicular bisector is actually not the perpendicular part, it's the bisector part. So the bisector part means that you're in the middle. So the midpoint of a line, okay, or the midpoint between 2 points, there is a formula for it, but I was just telling my students today, I was like, I always forget that there even is a formula for it. I just forget. It happens, right? Oops, I forget the midpoint formula. But the reason I forget it is because it's so simple to find it, right? You look at half the horizontal distance and half the vertical distance, right? Excuse me. So here, if I look at these distances, right? Here, this horizontal distance is 4. So halfway is going to be right here at 2. Half my vertical distance, let's see, my vertical distance is 6. So half of that is 3. This is the same thing as when you find fractional distance, if that's something that your teacher is working on, is fractional distance. So like if I was doing 1/3, I would do 1/3 of this. I would do 1/3 of this, right? Yay, Lucas, hello. All right, so we've got this one and this one. So we're gonna go where those meet up, which is the midpoint, which is right here. So since that's the midpoint, by definition, whatever passes through there is going to be a bisector, right? Because again, we got to cut it in half. So that is, the midpoint is where the bisector will be. So we've got the bisector part of perpendicular bisector. So now let's get the perpendicular part, right? So the perpendicular part, remember, we're looking for the opposite reciprocal slope. So we already talked about how, so this line has a positive slope, right? So our perpendicular one is going to have a negative slope, right? It's going to be somewhere, it's going to be kind of like this. Okay, but we don't want to just eyeball it. We want to make sure that we're looking at, we want to make sure that we really get it right, right? We don't want to just eyeball it. Okay, we can get to the equation question. Ratios, because we need to do that too. Ratios, do you mean like fractional distance? We can talk about that, but give me a little, Charles, give me a little more information about your ratios question. Okay, so here we've got this. So the slope of this line, let's see, we go over 4, we go up 6. So the slope of my original line here, the slope of my original line is 6 over 4. That's my rise over my run, okay? So that is 3 over 2, right? So the slope of this line is 3 over 2. I'm going to write that there, positive 3 over 2. So then my perpendicular slope, I'm going to change the sign, so it's going to be negative, right? And we already kind of saw that, like, oh, if it's going to be perpendicular, it's got to be negative, right? And I'm also going to, boop, flip it, right? So I'm going to do the reciprocal, okay? So that's going to be 2 over 3. My perpendicular bisector, remember, this is just like when you first learn how to graph lines, right? And they say, like, graph a line with this slope through this point. You go to that point and you use the slope and you find your next point. So again, a negative slope is going to go this way, right? This is kind of where we think our line is going to be, because that looks pretty close to 90 degrees. We'll get it exact, right? But it's going to be negative 2/3. So remember, it's rise over run. So we go up 2, and we're going to go to the left 3. And there's my point. And then I could go up 2 and left 3 again. I could also from here go down 2 and to the right 3. Okay, I can just play around with it wherever I want it to be. Okay, and then I'm going to connect the dots. However many points you need to put on there is fine. Okay, but at least 2, because you need 2 points to make a line. Okay, so that right there, that green line there, that is perpendicular because it's got that opposite reciprocal slope. And it's a bisector because this is the midpoint. Okay, so we know that this distance is the same as this distance. And we can double check because it's like over 2 up 3, Pythagorean theorem, right? 2 squared plus 3 squared equals this squared, great. And same as over here, right? 2 and 3. Okay, so that's how you do a perpendicular bisector on a graph. Okay, all right, so construct them. All right, let's see. This is an example of a question I need help on. A line passes through the points. Okay. All right, let's see. Okay. All right, so Charles, I'm going to answer Leah's question first. The line passing through the points 3K, 6. Okay. Ooh, this is a fun problem. All right, let's see. I'm going to get out my bigger coordinate plane for this. Okay. So, sorry, the screen's really hard. It's far away, so I'm having to really reach to see it. Okay, let's see. So a line passes through the points 3K, 6K minus 5. Okay, I'm going to write this down. So the point that you're looking for is 3K and 6K minus 5. And you've got to figure out the value for K that's going to give you that point. Okay, and then it's got a negative 1, 7. Okay, and a y-intercept of negative 5. So my b value is negative 5. Okay. My advice, anytime you're doing any sort of algebraic or even, I guess you could even probably say like any math question, like plug in what you know and solve for what you don't know, right? That's the first question you need to ask yourself. Not how do I do this, but like, what do I know? What do I know for sure? And then let's work from there, right? This is what I tell my students on the SAT all the time. Like, you're going to see things that you're gonna be asked questions in a way that you've never even thought about things. But if you can just dissect it to like, here's what I know, here's what I don't know, like these kind of things, you'll get into a much better space. Okay, so let's start with what we know. We know that it goes through the point negative 1, 7. I'm going to plot that point. Negative 1, 1, 2, 3, 4, 5, 6, 7. Let me double check that because my eyes kind of went cross. 1, 2, 3, 4, 5, 6, 7. Okay, so negative 1, 7 is there. My y-intercept is negative 5. Woo! 1, 2, 3, 4, 5. That is a steep slope. Whew! Okay. So, let's see. Leah, can you answer me this? What level of math or grade level are you in? I want to see what we're working with here. Okay, so we've got, man, that is quite a slope. Okay. Negative 7. The slope, I don't think this slope is negative 7. I think that the slope is much higher than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This slope is negative 12. Oh, are you guys both in the same class? That's exciting. Okay. All right, so geometry grade. Okay, so geometry. Got it. Okay. So here, so what we know about this, so let's start thinking about this, right? Slope-intercept form, I mean, I could put it into slope-intercept form, right? I know the slope, and I know the y-intercept. Let's see about slope-intercept form. My first instinct was to do point-slope form, but let's see how this works out. Let's see how it works out using slope-intercept form. Okay, so our slope that we found from there. Oh, were you saying negative 7 is k, the k value? I think that's what you were saying. It's negative 7. Okay, well, let's figure out how we know that. Okay, all right, so the slope is negative 15. Okay, and the y-intercept is negative 5. So as we know, right, slope-intercept form is y equals mx plus b. We know the m, we know the b, and we can use this x and this for y. And then we just solve for what we don't know, right? So here's what we're going to do. So we are going to, let's see, we're going to plug in what we know and solve for what we don't know. It's the oldest trick in the book. Plug in what you know, solve for what you don't know. So we know that our y value is 6k minus 5. Okay. We know that our slope is negative 15. We know that our x value is 3k. We know that our b value is negative 5. And now we're going to solve for k. Okay. Y equals Mathursday x plus b. Oh, Lucas. Oh, that's not Lucas. I can't read it from here. It's so small. I like that. Y equals Mathursday x plus b. Okay. All right. So we're going to distribute we're going to multiply with the negative 15. So we've got negative 45k minus 5 equals 6k minus 5. If we add 5 to both sides, that just gets rid of it. That makes it easy. So 6k, that doesn't work. Plus 5 plus 5. So 6k equals negative 45k. Is k 0? So that it's 0, negative 5. I mean, that would work. Yeah, I guess so. 6k equals negative 45k. The only way you can get that is if k equals 0. Oh, that is Lucas. I thought that was Lucas. Okay. So 6k equals negative 45k. So again, it's going to be 0 because, I mean, you could do plus 45k and then plus 45k. And then you have 51k equals 0. Well, k is going to be 0. So the value for k is 0. And that was the question, right? It was find the value for k that makes it part of this line, right? Well, if k is 0, then you're at 0, negative 5, because 3 times k is 0. 6 times k is 0, minus 5 would be negative 5, and 0, negative 5, that is this point. Oh, the point, got it. Okay. Makes more sense. Okay, so the point is not negative 1, 7. Well, I mean, still a good lesson, right? Okay. Let's start it over then. Okay, so negative 1, negative 7. I mean, honestly, we're not going to do anything differently. We're just going to come up with a different answer. Okay, so we've got negative 1, negative 7. Okay, that's gonna change things quite a bit. 1, 2, 3, 4, 5, 6, 7, negative 1, negative 7. And then, oh, our b value, our y-intercept is still negative 5. Okay, so that, in that case, isn't that interesting how that worked out, though? That was weird. Okay, so in this case, we've got, let's see, we'll look at our line again. So now our slope is actually positive 2. So our slope is positive 2, right? Because we go up 2 over 1. So our slope is 2. Great. Okay. So now, again, plug in what we know, solve for what we don't know. Lovely. So y equals mx plus b. So we know our y is 6k minus 5. M is 2. That's a lot nicer than negative 15. Times 3k, which is our x, and then plus b, which would be minus 5. Okay, so we've got 6k minus 5 equals 6k minus 5. That doesn't make any sense. See, because this is an infinite possibility. Yes, Charles, I can see your chats, but I wasn't looking at them every single second, so I missed all the things on there. So, I mean, here's the thing is if you just know that, I feel like this here, 3K, 6K minus 5, it feels like it's a bit of like a red herring kind of thing. Yeah, so K can be all real numbers. Like it's infinite solutions. It can be whatever it needs to be. Because if you have a point and the y-intercept, you can write the equation. Because you can find the slope just like we just did. And once you have that, you can do point slope form, or you can do whatever. But then putting this in, 6K minus 5 equals 6K minus 5, it's going to always equal that. They're always going to equal each other. Yeah, so the solution would be all real numbers. I'm not sure what kind of like notation or whatever your teacher wants, but maybe you would have like set notation that K can be all real numbers. If you need to use a set notation, that would be that, right? But again, if this were like not all real numbers, you would be able to solve this K for a specific value, okay? But I think that the thing that throws it off is the fact that this is the y-intercept is -5, just like that -5. And you've got this slope of 2, where this is 6, this is 3, so 2 times 3 is always going to give you 6. K equals a sideways 8. Yes, so it's there are infinite solutions for this. Yeah. Okay, let's see. Okay, Billy says he partitioned the directed line segment WK. Okay, by finding point C, which is at 5, -1. Okay, can I use my bigger one? Okay. All right, Charles, let's go over your question that you were asking. Okay. Oh, because, yeah, the ratios of distance, yeah, that's like fractional distance, right? So in a ratio of 1 to 2, right, if I have like, I mean, we can sort of demonstrate this. If I have 1 red for every 2 blues, you know, marbles or M&Ms or whatever, right? That is a ratio of 1 to 2, which means that it's in 3 sections, okay? So 1 to 2 would mean that it's in 3 sections again. We could kind of think about this as like a tape diagram, right? So you've got 2 that are blue, 1 that's red, right? So you technically have that. It's in 3 sections. If I had a line segment, if we just thought about a line segment here, and if I had partitioned it and I said, well, this section is 1x, this section is 2x, or you could say something along the lines of like, this section, I'll put some letters on this, D, E, F. Right? If you say that EF is twice the length of DE, or you could say DF is partitioned into segments of a ratio of 1 to 2. That means that one section is twice as big as the other section. So like what you actually have in total is 3x, right? So again, it's when you're partitioning it in a ratio of 1 to 2, it's different from 1/2, right? So 1/2 is part out of whole. So that means that there's one, you're talking about 1 part out of 2 total, right? A ratio of 1 to 2 means that for every 1, you have 2 more. It's part to part. So the whole in this is actually 3. So that's just kind of the subtle difference between ratios and fractions. They're written very similar, right? But if you say 1/2, okay, if you say 1 out of 2 or 1/2, that's very different from a ratio of 1 to 2, right? Because you're talking about that kind of like proportion and like related to each other. You're relating those 2 parts to each other, or the parts of the whole to each other, not the part to the whole. Okay. So let's talk about this one on the graph. Okay, so finding point C. Is TikTok just not working?
I think I figured it out.
Oh, okay. All right, so partition the directed line segment. Okay, I'm going to do, so WK, finding point C, which is 5, -1, and this created the ratio of WC to CK of 1 to 2. Given point K is -3, 5. Okay. So, wait, can you close out that community moderation that
Yeah, I can try. Oh,
just so I can see the chat?
yeah.
There we go. That's all. Okay. So before we put it onto the coordinates, let's just make sure that we understand what we're doing. So we've got this line of WK, and we're going to kind of do it in a similar way like we just did, just kind of talking about those. So part C is created the ratio between WC to CK of 1 to 2. So WC is the 1, CK is the 2. So WC is the 1 part, CK is the 2 part. So if we were doing this, right, it would be like this is X and this is 2X, just like what we just talked about with the ratios. Okay? So now that we understand, like now that we've kind of mapped this out, now let's move to the grid and figure out these coordinates. Okay? But what I'm going to be looking for is that the distance between W and C is going to be half the distance of C and K. Yeah.
Yeah, TikTok is just like dropping
That's
3
so
seconds
weird.
of, like, you know, a video every, it'll like pulse.
Huh. Okay. So we've got C is at 5, -1. 1, 2, 3, 4, 5, -1. I'm going to have to do this on the bigger one. Okay. Oh my gosh, Lucas, this is like a third of my whiteboards. All right, so 5, -1 is C. And then K is -3, +5. 1, 2, 3, 4, 5. Okay. And so I've got to figure out what W is. So now if I look at this diagram, right, I've kind of flipped it, right? So actually it should kind of be like this. You guys even see that? It's going to be K, C, and then W is going to be somewhere down here. Okay, so let's figure out the distance between K and C. And you can do this all without graphing it. You could just calculate the distance between the two, right? But I don't know, I'm a very visual person, and so I find it much easier to do this on the whiteboard. Okay, so the distance, we can do the distance formula, or we can just do Pythagorean theorem. 1, 2, 3, 4, 5, 6. So this side is 6. Let's see, 1, 2, 3, 4. Oh. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 6 squared, 8 squared. Oh, that's a 3, 4, 5 square, right? So this is 10. Okay. If you guys don't know 3, 4, 5 squares, sorry, 3, 4, 5 triangles, it's okay. This is just Pythagorean theorem, right? 6 squared plus 8 squared equals 10 squared. Okay. So this distance is 10. Now remember, this is twice the distance, right? So what we need to find is the point that is now 5, a distance of 5 away along the same line, okay? So what I know, well, with this being a 3, 4, 5 triangle, I can actually just go down 3 and over 4. And that's where my W point is going to be. So that's C and that's W. Okay, and the reason for that is because this is 3 and this is 4. Okay, let's see. If you don't know 3, 4, 5 triangles yet, that's okay. Okay, because what you could also do is you could like just plot, like go down 6 and over 8 again. But actually what you could also do is, this is sort of like going back to the midpoint conversation, right? Is that the midpoint of a segment that's 10 units long would be 5 units, right? And that would be half of this and half of this, which would give you that midpoint there, okay? So it's the same idea, right? You're just going to be doing down 3 over 4. So the coordinates for W would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and -4. There you go.
Kim on TikTok's asking, why do you think inequalities are so tricky for students?
I think it's that it's like an uncertainty, right? Like inequalities are sort of like an uncertainty, and you have to keep track of, they're not as intuitive, I think, especially when you start getting into like the negatives, right? And like, oh, now you have to flip the sign. And then to check them, like if you're graphing them on an actual like graph like this, when you have to check them, again, it's not intuitive. It's just sort of like, yeah, then you just pick a point and see if it works or if it doesn't. And students don't like uncertainty. And so when you have like this range of values, I think inequalities, especially when you're first learning them, they really lend themselves to story problems, and they make a lot more sense, right? Like, oh, if you can't go over this, then it has to be less than that, right? Or if you can't go less than this, it has to be over that. So I feel like when we first start teaching inequalities, kind of staying away from like the calculations and things like that until you really get into algebra and yeah, like the alligator, and like comparing numbers, I think is fine, the greater than or less than. But as far as like when you're working with an inequality, that kind of thing, stick with the story problems for a while, because yeah, I think it's the uncertainty piece. I think that's just what they don't like, is that it's like squishy. It feels squishy. Yeah. Any other questions?
Not from TikTok. The big question is, why is TikTok so crazy today? Like, the upload rate, I just double checked it, and it's 170 megs, and it's only getting kilobytes out of the encoder, so.
That's so weird.
And then I just noticed that it was not super focused either, which was the up top one.
No, Charles, listen, it is you, one other person, and me in here. Ask away. Ask whatever question you need. I am here to help. I am happy to help. This is what I do all day. Answer questions, talk about math, do math. Oh, kids were so excited when I busted out the Skittles and the M&Ms. We did a little candy activity in my honors class today.
Can you do a couple fractions?
Mm-hmm.
Love those fractions.
Love those fraction problems. Yeah, Charles, ask another question. I'm going to do some fraction problems. 4/5 plus 7/8. Okay, so when we look at these, All right. Let me work out this problem, Charles, and then I'll work on yours. Okay, so 4/5 plus 7/8. When we've got these fraction problems, right, we're going to do a little bit of an estimate first. 4/5 is almost 1. 7/8 is almost 1. So if we're adding them together, we're going to expect it to be almost 2. Okay? So we want to make sure that we have common denominators, right? Easiest way to do that is multiply this denominator by the top, right, by this numerator. So that would be 32. Multiply this denominator by this numerator, and that's going to be 35. Our symbol stays the same, and then we multiply these together. And since they're the same denominator, when I multiply it together, I can just stick it right there on top. So this is going to be 67. 67. Said it so confidently too. 67 over 40. So then we have 1 and 27 over 40. Can I simplify that? No. 3, 9. Nope. So it's 1 and 27 40ths. So almost 2 again, right? So our estimate was about right. Okay. All right, so Charles, let's take a look at your question. So it's asking you for the distance between the two lines. So the only way that you can answer that is if they are parallel lines. Okay, now looking at your equations, they are, but I'll show you how to double check that, right? But really, you don't even really need to check it. You can just, graph it and make sure they're parallel, okay? But parallel lines have the same slope, right? They go at the same angle, so it's the same slope. If they have different slopes, even a teeny tiny bit different, eventually they're gonna run into each other, right? So parallel lines have the same slope, exactly the same slope. Okay, you can graph any line by just plugging in some points, okay? So we've got, let me grab my big board again. I really like using this big board. Okay, so we've got 2x minus y equals -4. 2x minus y equals -4. So again, you can always graph a line by making a table of values, but you can also, if it's easy to put it into slope-intercept form, that works too. So I'm going to subtract 2x from both sides, and I have -y equals -2x minus 4. I'm going to multiply everything by -1 because that y needs to be positive. So I have y equals 2x plus 4. So that I can easily graph, right? Okay, the other one is x equals 1/2 y plus 3. So, I'm going to have to do this one over here. X equals 1/2 y plus 3. Okay. I'm going to flop this order. So it's 1/2 y plus 3 equals x. Subtract 3, subtract 3. So that gives me 1/2 y equals x minus 3. I want to get that y by itself, so I'm going to multiply everything by 2. Because 2 times 1/2 is 1, so that gives me y equals 2x minus 6. So this way, I can verify that they both have the same slope, right? So that means that they are at least parallel. Now, if they also had the same y-intercept, which I wouldn't be surprised if your teacher puts a question like that on the test, right? And then you go, oh, the distance is 0 because they're the same line, right? If they have the same slope, different y-intercept, they're parallel. If they have the same slope and the same y-intercept, they're the same line, right? What is it? Looks like a duck, sounds like a duck, is a duck. Okay. All right. So let's graph these two puppies. All right. Let's do y equals 2x plus 4. So for graphing these, when you've got them in slope-intercept form, right here we're going to do y equals 2x plus 4. So I'm going to go up to 4. That's where my y-intercept is. And then I'm going to go up 2 over 1, down 2 over 1. I can use a straight edge. I'm just going to use this one. Okay. I can use a straight edge to graph this whole line. So it's the slope of 2, right? And do you have to graph these? No, you actually don't have to graph them. I'm going to do my best. It's always kind of hard to graph with dry erase markers. So the lines are thick enough for you to see them and thin enough to not throw off your calculations. But okay. And then we've got 2x minus 6 here. So we've got 1, 2, 3, 4, 5, 6 is here. And then up 2 over 1, up 2 over 1. So I can make a bunch of these little things here. Okay. So I've got this one. Okay. So now we have shown that these, where am I? Oh, there's my cap. Oh my gosh. Okay. So now we see that these lines are parallel. Okay. Hold on just a minute. Okay. I didn't realize that that had a specific name. The distance between two parallel lines is the perpendicular. I didn't know that. Interesting. Very interesting. Okay. All right. So the distance between the two parallel lines, I just wanted to make sure that it was what I thought it was, which is the perpendicular distance between the two lines. So this goes back to what we were talking about before, which is with the figuring out the perpendicular bisectors, right? So we need to draw a line that is perpendicular to, both of them, because it's going to be perpendicular to both of them, right? And then we'll figure out the line, we'll figure out the length of that perpendicular line. It doesn't have to be a bisector. It can be through whatever point. I'm just going to kind of pick that one because I know for sure that it passes through this point. Okay. All right. So remember the slope for each of these. The slope is 2. So the perpendicular slope is going to be -1/2. Okay. So from here, I'm going to go down 1 over 2, down 1 over 2, and it's going to intersect right there. Now, do I have to fully draw it out? No, but I'm going to because I want to. So that right there looks sort of like Baymax, but I'm going to go perpendicular right there. That is the distance between those two lines. Okay, that perpendicular line. What was it? What did I just say it was called? The perpendicular. I had no idea that that actually had a name. The perpendicular. Okay. And there is a formula for this, but again, I don't like memorizing formulas. So I just figure it out. All right, so the distance between these 2 points, right? We look at, we can do Pythagorean theorem, or we can do the distance formula, right? Luckily, it looks like it passes through these two exact points. So we've got down 2, we've got over 1, 2, 3, 4. So if we bring in our Pythagorean theorem, right, we've got, I'm going to go over here. Right, I don't really like this black marker. So we've got 2 squared plus 4 squared equals c squared. And we're going to call this c, that distance there. So we have 4 plus 16 equals c squared. Do you need to round this, or do you need to like, are you supposed to round this, or do you need to leave it as a radical? That's the question, right? So if I take the square root of both sides, I would have square root of 20 equals c. I don't know if you need to round that, or if you need to simplify this as a radical, it would be 2 root 5. I'm going to guess that since it's asking you for distance, you probably need to round it. So then you would just find the square root of 20, which, square root of 20 is about 4.5. 4.47, but we'll call it 4.5 units. Okay, so if you left it as a radical, again, it would be 2 root 5. So either way. All right, so what if the slope was a wacky fraction? How would you find? It doesn't change. The perpendicular slope is always the opposite reciprocal. Even if this slope was something like 7/9, the perpendicular would be negative 9 over 7. It doesn't matter what the fraction is, it's always the same. Okay, just because this is 2, this is still going to be, you flip it and you change the sign. Okay, so if it was like negative 13 over 15, the perpendicular would be positive 15 over 13, right? The rules never change just because it turns into a fraction. Okay, so you would still find it the same way, the perpendicular. Okay, I just realized I'm leaning out of the frame.
You're fine.
There's a big delay on what's on the monitor.
Yeah, it's going up to the internet and then coming down.
Wowzer.
I mean, you can just watch, let's see, you can't watch it on there.
No, it's fine. If you use the y-intercept, how would you find the point perpendicular to that on the line? If you used the y-intercept, you're talking about using the y-intercept on the blue line? Oh, if I didn't use the y-intercept? Oh, So there is a formula for it. You really want to use a formula? There is a formula for it, but has your teacher shown you the formula for it? So if your teacher's given you the formula, then sure, you can use the formula, but it's not a very fun or intuitive formula. Like, this would honestly be almost like faster. Where you find the equation of the red line and find the perpendicular line to the blue line and put those equal to each other because they're both y equals something. Oh, like a system of equations? I mean, because if you're given... I mean, that's like a system of equations where you're trying to find the intersection. Okay. Yeah, so if I were to... Okay. I mean, yes. So what were the... Let me see. So you were given... you were given 2x minus y equals -4. Okay. And you've got x equals 1/2 y plus 3. But like, it's just so complicated. Oh, that's just a much more complicated way of doing it. But I guess if that's what your teacher wants you to do, then sure. So then you could find the equation of this perpendicular line, right, that goes through the y intercept. So here, so if we take this equation, so remember we rewrote it into into slope-intercept form. So we get y equals 2x plus 4. So then the line that's perpendicular to that passes through that same y-intercept, so the perpendicular version of that would be y equals -1/2x plus 4, right? That equation would match up with this line here, this black line here. Okay, so then... if you write the blue line, let's see, we got the blue line out to be y equals 2x minus 6. And I'm just looking at what we did before, right, with getting it into slope-intercept form. So then if you're trying to find, if you're trying to find where they intersect, then where they intersect would be where these y values are the same, right? Where the y values are the same and the x values are the same. So now it's just like a system of equations. So you're just looking for their intersection point, which we know is going to be 4, 2. But, so you set them equal to each other. So you have -1/2x plus 4 equals 2x minus 6, right? Because you want to figure out the point where this y is the same as this y. Let's see. So this would be, we can add 6. Add 1/2, so we've got 10 equals 2.5x, right? So then 10 divided by 2.5, right? 10 divided by 2.5, you're going to have is 4. I don't think you guys can see that, but. So x equals 4. So we know that x is 4. And then we would plug that back in up here, right? 2 times 4 is 8. 8 minus 6 is 2. -1/2 of 4 is -2. Plus 4 is 2. So we have y equals 2. So then you would have, this is your point, which is 4, 2. So then you would have to calculate. See, this is why graphing is so much better. So then what you're trying to find is the distance between this y-intercept and this point right here. So then you would do the distance formula. You would do the distance formula between, excuse me, the distance formula between 4, 2 and 0, 4. Okay, so then beyond that, sorry, I'm gonna pull this up really quick. But it is much easier. Anyway. Okay, so then you've got your distance formula, which is square root of x2 minus x1 squared plus y2 minus y1 squared. So that's going to be 4 minus 0, so we've got 4 squared plus 2 squared. So we've got square root of 16 plus 4, so we've got square root of 20, which is 2 root 5. Okay, so that is how you would do this without graphing it. 0 stars, don't recommend. I don't know. I just really like graphing. Graphing to me is just easier to visualize and understand, and you can just literally just count boxes, right? You can count those boxes and then Pythagorean theorem. But again, like some teachers are going to require you to do this. It depends on where they're going next, right? Far be it from me to judge what another teacher is doing and requiring in their class, because I'm sure there's stuff that I require in my class that other teachers are like, what? What's going on with that? Like, for example, I don't teach proofs. I don't do them anymore. It's my little hot take on geometry. Anyway, so yeah. All right, Charles, last question. If you have any more, if you're good, then we're good. We can do one more question. But what's nice is that you can check it with the graphing. That's really nice. I was even telling my students the other day, I was like, with the SAT, if you can provide your own scratch paper, make it graph paper, because you can always graph stuff. So much easier. I know. This is why I don't do proofs. If you need to learn how to write proofs, go take a class in college. But otherwise, you need to like support your reasoning, of course, like logically support your reasoning and all of that. But writing a formal proof, thumbs down. Okay. All right. So Charles, are you good for your test? Okay, of course. Anytime. I'll be back next Thursday also. Yeah. All right. Have a good night. Bye.